So now this video discusses on how we can be able to determine whether the given two lines in a space are parallel lines or they are not parallel lines. That's the point of interest. So one thing that you have to understand is that in order to come up with the equation of a line in a space, we just need the single point and the parallel vector to the said line, and that vector it is known as the direction vector. And for instance, let's consider, let's say this is the line in a space. And let's say the line passes through at some point. Let's say that is a point Q with a coordinates given as, let's say, x naught, y naught. Should be x naught, y naught, as well as the c naught. Let's say that is the case. And assuming that there is a what you call as the direction vector, and a vector which is parallel to the line, let's say given as should be v1, and the direction vector is given as, let's say, a, b, as well as the c. Those are the directional values. And now let's say we have another line. By the way, this is given as L1, that is a line 1, and we should have, let's say, this is the line 2. Let's say the line 2 passes through some point, let's say that is the point B, with coordinates given as x naught, y naught, as well as z naught. Let's say that is the case. And now let's consider this line having its own direction vector. I'll call it as v2. And with the direction values given as a, b, c. And now if these lines are said to be the parallel, it means whatever the case, their vectors must also be actually parallel as well. And hence, these vectors must obey the principle of the parallel vectors. So for us to prove analytically whether these two lines are parallel or not, we should use the vectors, because the vectors has to be parallel if the lines are said to be parallel. So stuff it as that. So therefore, what it tells is that, using the principle of the parallel vectors, it means, a vector 1 has to be equal to the scalar product of a vector 2. Now, if the lines are said to be parallel, it means the direction vectors must have to obey that principle. And think about this. Let's say we have the line 1. Let's say we have the line 1. It should be, which is given as, let's say, x minus 1 divided by, let's say, 4. And that should be somewhat about, let's say, is equal to, let's say, y plus 5 divided by, let's say, negative 2. And that which is equal to, let's say, z plus 9 divided by, let's say, 3. And that we have, let's say, line 2, which is given as, that which is given as x plus 4. And let's say, divide by, should be 2. The which is the same as y minus 4 divided by, let's say, 4. And the which is equal to, let's say, z plus 18, and thus divide by negative 6. So how do you think we start this? And by the way, this has to be given as, and this is given as 8. That should be negative 80. And we should have, and by the way, let me just have to use that one. It should be the same. So how do you think we have to determine if these two lines are parallel or not? So the first thing is that we have to determine the directional vector for the first line, and that corresponds to have them as that its components are given as that. So we have the value of a, and which is given as 4, and b is given as negative 2, and c is given as 3. And we should also have to determine the direction vector for the line 2, that is given as 2, 4, and negative 6. And therefore we should have to determine if these two vectors are parallel, and thus they have to obey this principle. So vector 1 has to be equal to the scalar product of the vector 2. And hence we should have it being somewhat about What is the vector 1? That is, we have it as 4, negative 2, 3. And that's giving us that, which is equal to k times. What is vector 2? That's 2, 4, negative 6, like that. And therefore, have it as 4, negative 2, 3. And that which is equal to 2k, 4k, and negative 6k. And therefore, we have to equate this componentry. That's how we should have it as, should be x component. We should have it as 4 is equal to 2k, and therefore a k is given as, should be 2. And the y component, we should have it as negative 2 is equal, that's 4k, and that's k is given as, should be negative 1 over 2. And the z component, what it does is that we should have it as 3 is equal negative 6k, and thus k is equal to negative 1 over 2. And now since the values of k are different, then the actually vectors are not parallel, hence the lines are not parallel as well. So that's how you should have to conclude that and understand. So how about, let's say this is the case. Let's say we have, let's say this is the line 1, which is given us, should be x is equal to, should be 6 minus 3d, and we have y, which is equal to, should be negative 2 plus, let's say 2d, and we have another line, let's say line 2, which is given us, let's say x is equal to 16d, and we have y, which is equal, and by the way, we have a z here. What is the z for that? It's given us 5 plus, should be 14. And what is that? It was given as 2 minus 40, like that. And we should have c, which is given as 13 minus, should be 80. And now from this point, we should have to determine what is directional vector phi1. So in this case, we should have the components of the t, and thus we should have it as negative 3, we should have 2, and positive 4. And we should have the direction vector for the line 2, we should have it as, should be 16, and that's negative 4, and we have it as negative 8. Those are the direction vectors. Then according to the principles behind the parallel vectors, so which means one vector has to be equal to the scalar product with another vector. That's why I have it as negative 3, 2, 4, that which is equal to k times c. What is that? 16, negative 4, negative 8. We'll have it as that. So therefore we have to distribute k. That would be given as, should be 16k, negative 4k, and negative 8k, like that. And that's negative 3, 2, it should be 4 rather. Just have it at 4. And now from there, we have to equate them componentry, in the sense that if we start with x component, we'll have it as negative 3 is equal to 16k. And thus k is equal, should be negative 3 over 16. And I should also have the other case, thus 2 is equal to negative 4k. And therefore k is given as 1 over negative 2. And in the other case, 4 has to be equal to negative 8k, and therefore k is equal to negative 1 over 2. And now since these values are different, since these values of k are different, it means the vector, actually it means the vectors are not parallel, hence the lines are not parallel as well. So the second have it as that. So that's the principle behind the vectors. It should be behind the parallel lines on the context of the parallel vectors. Thank you.